Right. Good day, everyone. In this lesson, we're going to be multiplying polynomials. Last lesson, we talked about polynomials and we defined them. So we'll be multiplying them here. When we multiply polynomials, we're going to multiply numbers first, and then we're going to multiply the variables. Remember, when you multiply with the same base, you have to add the exponents. And then you're going to simplify or combine like terms if you can. Gentle reminder, when I tell you to pause and try the problem, you do want to pause and try the problem before you view the solution to the problem. All right, so let's look at number 1 and get started. We are going to multiply numbers first. So we have 5x squared times 4x to the third. The number is 5 and 4. So I'm going to multiply 5 times 4 first. 5 times 4 is 20. Then I'm going to multiply the exponents. So that is x squared times x third. When we multiply with the same base, remember we add exponents. So that becomes x to the 5th power. And then can I combine like terms? No, this is it. I'm all good. 20 x to the 5 is my answer. Let's look at number 2. And I think I'll break down number 2 a little bit more for you. We have 2 RT t times t to the 5t to the third. So again, numbers first. That's going to be 2 times 5. And then you go with the variables. So then we have R2. There's no more, so it's just R times R, or just R2. Then we have t to the 1 power. Get orange. T to the 1 power and t to the 3 power. So times t to the 1 power times t to the 3rd power. That's what's happening. Those are all the variables. And so 2 times 5 is going to give me 10. R squared, there's only 2 of those r's. There's no more in the other one. So it's just r squared. And then I have t to the 1 power here and t to the 3 power. Well, 1 plus 3 is going to give me t to the 4th power. And it doesn't necessarily matter the order because they are being added. This, indeed, when you're done, is going to be a monomial, and the highest degree is going to be 6. Leading coefficient is going to be 10. Let's look at number 5. Oh, 5 looks fun because they're all being multiplied. So again, numbers first. This number is 1/2. This number is technically 1. And this is a 6, y'all. Don't laugh at my 6. All right. So numbers-wise being multiplied, we have 1/2 times 6. And that is 3. Then we're going to multiply the variables. I just take the next variable I see right down the line. So I see a to the 3rd. Well, this one has a to the 2nd. And that one has no a's. So I have a to the 3rd power times a to the 2nd. I have 3 a's and 2 a's. Altogether, how many a's do I have? 3 plus 2 is going to give me a to the 5th power. Now let's look at the b's. Again, we're all being multiplied. I have a b in this term. So that's b to the 1 power. No b's here. And then I have 2 b's over here. Well, how many b's do I have? 1 b and 2 b's that are being multiplied. Altogether, I'm going to have b to the 3rd power. There's 3 of them. 1 plus 2 is 3. Now, I'm done with all the terms in the first parentheses. Let's look in the next one. The only thing I have missing is a c. So I'm going to get that c term. And there's no other C term anywhere else around. So all I have is two C's. 3a to the fifth power, b to the third, and c to the second. That is my monomial. The degree of this monomial would be 10, 5 plus 3 plus 2, and the leading coefficient is 3. I want you to now try number 3 and number 4. Pause and try 3 and 4. All right, now that you are back, let's start again with numbers first. When we're multiplying, 3 times 6, numbers first, is going to give me 6 is 18. Then I have x third times x the second. Well, this is 3 x's, and we're multiplying it by 2 more x's. Altogether, we add those exponents, we're going to have 5 of them. So 18x to the fifth power. Let's look at number 4. We are going to multiply numbers first. Negative 3 times 4 would have given you negative 12. And then you move on to the variable, so x to the third. There's another x over here, so now it's x to the fourth power. Then we have y to the second power times y to the fifth power. Now altogether, there's y to the seventh power. And that's it, folks. That's multiplying monomials, 1 and 1. Now, what if we are multiplying a polynomial by a monomial? Now we have a lot of terms that we're working with. We're going to use the distributive property, and we're still going to do one at a time. Right? So I usually like to put the monomial first. So if I see this whole big trinomial in front of the monomial, I like to flip it and just put the monomial first. It helps. So that's negative 3y times 2x squared plus x plus 4. So I'm going to start again. Monomial to monomial. Numbers first. Negative 3 times 2 is going to give me negative 6. And y times, oh, there's no more y's here, so it's just the y. And then we have the x squared. Go ahead and pause and kind of look at what just happened there. After I finish the first term, I'm going to multiply that same negative 3y monomial to the second term. Well, what's the number in front? It's a 1. So negative 3 times 1 is going to give me negative 3. Y, no more y's in here, so it's just a y. And then I still have an x. So this becomes negative 3yx. I'm going to do it again. And it's going to be the monomial times that last one in there, which is a 4. Numbers first. Negative 3 times 4 is going to give me negative 12. And y, no more y's in here, it's just y. Is this in standard form? Well, the degree here is going to be 3. This is 2, and this is 1. So yes, this is in standard form. I am done. I always want to make sure my answers are in standard form when I am finished. Let's look at number 2. My first monomial, 2x squared to the y, I'm going to multiply it by the binomial now. This was a monomial times a trinomial. Now we're doing the monomial times the binomial because there's 2 terms. All right, remember those vocabulary. So we have 2xy times 3x. Numbers first. 2 times 3 is going to give me 6. X squared times x is going to give me x to the third power. There's 3 of them. And y, there's no more y's here in this term, So it's just a y. I'm going to go ahead and multiply the monomial by the second term, which is just the y. So again, number 2 times -1 is going to give me -2. X squared times y, there's no more x's over here. It's just x squared. And then the y, there's another y here being multiplied, is now y2. So numbers, variable you see, and then the next variable. How many are there? And now let's see. We have x to the third and y. That degree is 4. And 2x squared y2, this degree is 4. In this case, it doesn't matter which comes first because both of them have a degree of 4. The polynomial has a degree of 4. So it's going to be a quartic binomial. Let's look at number 4, and then I'm going to let you try number 3. So again, this is now a mono times a binomial. I'm going to multiply it by the first term in the binomial. 5 times 1 is just 5. R squared and R now makes 2 plus 1, R to the third, 3 of them. And S squared, there's no S's in this first term, so it's just S squared. Now let's go ahead and put it with another color green. This whole binomial is going to get multiplied by the second term. 5 times -3, number first, is -15. R squared times S is just R squared because there's no more R's here. And then S squared times S, this is an S by the way, is going to give me S to the third power. My degrees are still the same, so it doesn't matter the order. I'm good to go. Go ahead and pause now and try number 3. All right, now you're back. For A times A squared B, the first term in the binomial, this is a mono and a binomial again. But the first term, 4 times 1 is just 4. A times A squared is going to give me A3. And B, just the B because there's no more A. Now I'm going to multiply it to the second term. 4 times 2 is 8. 4 times, I'm sorry, I did the 4. So A times no more A's is just an A. And I have a B squared and no more B's here, so it's just B squared. This has a degree of 4, and this has a degree of 3. 4 and 3. So they are in standard form. We are good to go. So that was a polynomial by a monomial. Now we're going to do a binomial by a binomial. When we do the binomial by a binomial, we're still following the same process. It's just a little bit more, right? So there's also another term that they use, first, outer, inner, last. It's the FOIL method, but we're still at the end of the day distributing, multiplying. So we're going to start with the first term in the first binomial to the whole second binomial, meaning I'm going to go with x times x, first term and first term, and that's going to give me x squared. Then, I like it. I'm going to go with the first term to the second term. So I'm still using the x. X times 2 is going to give me 2x. Now, when you make the arrow, you have to follow the arrow. You can't make an arrow and then don't do it. As soon as you make the arrow, you follow through. Then we're going to multiply by the second term in the binomial. So that's 3 times the first term here, which is 3x, 3 times x, which is 3x. And then you're going to multiply that second term all throughout. Distribute it. So 3 times 2 is going to give us 6. Once you have distributed that second term, you're going to have 4 terms, if not more, depending on the situation. You simply need to combine like terms. So I look and I do have like terms, 2x and 3x. So now I have x squared plus 5x plus 6. Any more like terms? No. I am all done. And I am left with a quadratic trinomial. Let's do it again. You're going to start with the first term in the first binomial and distribute it throughout the entire second binomial. So x times x, which gives us x squared. And x times -5, which is going to give us -5x. We are then going to multiply the second term, distribute rather the second term in the binomial. So that's 2. 2 times x is going to give us positive 2x. And then 2 times -5 is going to give us -10. Then you want to check if you have like terms. Tend to be, we usually will. So -5x plus 2x, those are like terms. It's going to give me x squared, what's that, minus 3x minus 10. That is my answer. This applies to the first, outer, inner, last because you multiply the 2 first terms, then you multiply the outer terms, then the inner terms, the 2 and the x, and then the 2 last terms, just like distribution. If I see something like number 3, x plus 5 squared, remember a number squared, 5 squared would mean 5 times 5, which is 25. Well, x plus 5 squared means x plus 5 times x plus 5. Now go ahead and pause. I'm going to pause. Well, you pause, and you're going to try number 3, and you could try number 4. All right, now that you have tried 3 and 4, let's go ahead and FOIL. So x times x would have given you x squared, and x times 5 would have given you 5x. Then you would go below. 5 times x would give us 5x, and 5 times 5 would give us 25. And so we will get x squared plus 10x plus 25. You want to be conscious of that middle term, because if you just tried to square it, you would think your answer was x squared plus 25. No, that shortcut will not work. That's my answer. Now let's see if we had done number 4. You should have had x minus 5 times x minus 5, because that's what this squared is going to tell us. And then we are going to FOIL it. So x times x will give me x squared. X times -5, -5x. -5 times x. That's the negative. Oh, no, it's right. -5x. And then -5 times -5, which is positive 25. Then you would simplify your terms. You get x squared minus 10x plus 25. Now let's look at number 5. You can, but I wanted to do it because it might be a little challenging. It's still first term and first term. Numbers first, so 3 times 1 is going to give me 3. A squared times a squared is going to give us a to the fourth power. Then you'll multiply it by the second term. So we have number times number, -6, 3 times -2, -6. And then a squared, that's all we have, so a squared. And then we have a b. Now we're going to do the next one underneath. So -b times a squared is going to give me -b a squared. And then we have -b times -2b. -1 times -2 is going to give me +2. And b times b is going to give me b squared. Now this comes a little tricky because you're wondering if you have like terms. And at first it doesn't look like these are like terms. But a squared b is the same as ba squared. Let's flip it because sometimes that makes it a little bit easier to see visually. So that we have 3a to the 4 minus 6a squared b minus a squared b. I'm just moving those two around so that it looks like this, which makes it easier to recognize. So plus 2b squared. So now let's go ahead and combine like terms. Now they look nice and matchy. And my answer is 3a4 minus 7a squared b plus 2b squared. And is it in standard form? A4, fourth degree, A2b, that's 3, and b squared is 2. So yes, this is in standard form. Nice. Now we're going to lastly multiply polynomials with more than 2 terms. This is crazy. Same process. We're going to start with the first term. X times x squared is going to give me x to the third. X times -5x is going to give me -5, numbers first, x squared. And then x times 4 is going to give me +4x. Then we're going to do the next term. I like to always do that next term underneath. So 2 times x squared is going to give me 2x squared. 2 times -5x is going to give me -10x. And 2 times 4 is going to give me 8. That's it. From here, I'm just going to combine like terms. So x cubed, there's no more of that. I just have x cubed. And then I have x squares around, -5x squared plus 2x squared. That's going to give me -3x squared. Then I have 4x minus 10x. That's going to give me -6x. And then I have an 8. Do keep in mind that adding and subtracting is going to be different than multiplying, right? We're just combining like terms when we add and subtract. When we multiply, we're multiplying. And so, boom, this is in standard form. Yay, good to go with my cubic polynomial. Go ahead and try number 2. Actually, let me do number 3 with you first, and then you try number 2. Number 3 is kind of because it's x minus 2 cubed. But if you remember in the days, if I had 6 cubed, it meant 6 times 6 times 6, right? So x minus 2 cubed is going to be x minus 2 times x minus 2 times x minus 2. For that, you want to do the binomial and binomial first. So you would have x minus 2 times x minus 2. Go ahead and pause and try. So you should get x squared minus 4x plus 4. You only took care of 2 of them. Now that you have this trinomial, then you could multiply it by the last x minus 2 binomial. All right, go ahead and do that. Pause and do that. And number 4. So finish number 3 and then also do number 4. So, right, so final answer should have been x squared minus 6x squared plus 12x minus 8. Let's look at number 2. Once you would have done it, you would get negative 6x to the 4th power, and then 15x squared, and then negative 18x, followed by the bottom one, negative 4. So that's going to give me a positive 8x3, a negative 20x, and a positive 24. Then I'm going to combine like terms. My highest degree is 4, so I have negative 6x to the 4. Then I have only one x to the 3rd power, so a plus 8x to the 3rd. Then I have, 1x squared. So a plus 15x squared. And then I have a negative 18x and a negative 20x. So we have a negative 38x and then a plus 24. And I can't combine any other terms, so here we are. A quartic polynomial with a leading coefficient of negative 6. All right, have a wonderful day. All done.